Okay, so today we are beginning with a really simple chapter which goes by the name periodic table. So most of the chapter has already been done in class 9. Class 10 may very small part is there, but it is important it comes in the exam. So 10 to 12 marks so definitely comes in the exam. But main part जो था, that was Dobbernius triads and Newland's octet and all that stuff, that is now not there in the syllabus. I guess in the textbook it is there, but it's completely not there in the syllabus. Syllabus में only wait, I will tell you. If you're referring Viraf Dalal textbook, then directly come to page number 8. So from page number 8, see this page. Come here. उधर से जो definitions है, from there it starts. And then the trends. मतलब when you go from left to right, what happens? Right to left, what happens? It increases, decreases, all that things. But starting ka part you can completely skip. It is not there in the syllabus. Though it is there in this textbook, it is not there in ICSE prescribed syllabus. So, as I said from page 8, the first thing on page 8 is atomic radius. I'm not going into the pehle ka things that was Dobbernius tries Newlands and then Mosley gave that new modern periodic law. Then Mendeleev gave a brilliant law, Mendeleev's law of periodicity. I'm not going into that because वो सब तुम लोग I expect तुम लोग के ninth में किया होगा already. So directly beginning from atomic radius. So atomic radius definition is important. Do it from the textbook. Atomic radius simple. क्या होगा? Atomic radius, what do you think? क्या होगा? चलो, think. These are the shells of the atom. Okay, and here it is the nucleus. न्यूक्लियस के अंदर क्या है? न्यूक्लियस के अंदर है न्यूट्रॉन्स एंड प्रोटॉन्स. नॉट ट्राई showing them, but they are there. And इधर लास्ट में इधर इलेक्ट्रॉन्स. I'm just showing five of them. Maybe phosphorus or six चलो sulfur करते. So okay, yeah. So atomic radius का definition mainly is distance between the center of the nucleus. See, this is the nucleus. Okay, this is the nucleus. Center of the nucleus and the outermost shell, which is also called as the valence shell. So atomic radius is defined as the distance between the center of the nucleus and the outermost shell. That is all. भी इसमें और कुछ नहीं है. इतना ही definition. There is nothing else definition in this. यही by heart कर लो now. If you're not understanding, रट्टा कर लो. Nothing else there. So once you do the definition, you need to see the trends. So trends, what do I mean by trend is when you go from left to right, what happens? When you go from right to left in the periodic table, what happens? That all we need to check. Before that, we need to know the factors which affect it. Factors affecting atomic radius. So the first factor and the most important is number of shells. Obvious. अभी इसमें देखो ना, अभी ऊपर वाले यही एग्जाम्पल में देखो. This has how many shells? The upper one has how many shells? In the example which I have given. 1, 2, 3. 3 shells, right? So it has 3 shells. But अगर मैंने इधर और एक बनाया, say this is the nucleus and I have K shell, first shell and the last shell. बस दो ही है. इधर मैंने 2 इलेक्ट्रॉन दिखाए, इधर मैंने एक दिखाया. सपोज लिथियम बना. तो ऑब्वियसली अभी ये जो है, ये दिस इज नॉट लिथियम, आई एम जस्ट गिवन अ नेम ऐसे ही, बट जस्ट टू रिप्रेजेंट इट आई जस्ट सेड इट. ऑब्वियसली इसका जो एटॉमिक रेडियस है इससे बड़ा ही होगा कि शेल्स इसमें ज्यादा है, बीच में न्यूक्लियस है. If the shells are increasing, then obviously the atomic radius will increase. So number of shells increases, atomic radius increases. This is the first fact. Second factor is nuclear charge. Now this is something new. Second factor is nuclear charge. So why nuclear charge? So nuclear charge definition is also given. The definition is not there, won't come, but to understand it, you can just read through the definition. Okay, what do you understand by the term nuclear charge? Nuclear charge means the total charge of the nucleus of an atom. What is the nucleus of an atom comprised of? Now I'm drawing just the nucleus here. Either shells होंगे, there are the shells है, but I'm not going into that. Either neutron है, proton. Some 5 neutrons say 5 proton. I don't know. कुछ भी, it can be anything. It could be neutrons. Neutrons have zero charge, but protons have charge, positive charge. So the total charge of the nucleus, which is actually the charge of the protons, but we say the charge of the nucleus because protons are inside the nucleus. So the total charge of the nucleus is defined as the nuclear charge. अभी इसका ट्रेंड कैसा है? अगर न्यूक्लियर चार्ज बढ़ा, नाउ थिंक, if I am pulling something from if I'm say for example I'm pulling something, so it will come towards me, right? So if similarly if the nuclear charge is increasing, which means यहाँ के जो इधर के जो इलेक्ट्रॉन्स है लास्ट शेल में, उन्हें अगर मैं खींच रहा हूँ, तो they will tend to come towards it, right? So shells will come towards the nucleus. So see, to keep it simple, if nuclear charge is increasing, atomic radius decreases. Pulling. See, the textbook what is given. Electrons in the outermost shell are attracted with an increasing force. Exactly the same. They are attracted. अभी ये जो यहाँ के जो इलेक्ट्रॉन्स है उन्हें खींच रहा है. This center is attracting. They are attracted towards it. And that's why if the nuclear charge increases, atomic radius decreases. So now we talk about the trends. So trends of what? First we will check across a period. Across a period from left to right. Now when you go from left to right, what happens is when you go from left to right, the number of shells remain the same. नंबर ऑफ शेल्स तो सेम ही रहता है ना. नाउ चेक, अभी इधर मेरा सपोज सोडियम है, फिर इधर मैग्नीशियम, फिर अल्यूमिनियम, फिर इससे बीच में इधर गैप है, इधर गैप है जो सिलिकॉन है, फिर अदर फॉस्फोरस, सल्फर. सब में नंबर ऑफ शेल्स तो सेम ही है. इसमें 281 कॉन्फ़िगरेशन है, 282 है, इसका 283, बट इसमें भी 3 है, इसमें भी 3 है, इसमें भी 3. नंबर ऑफ शेल्स इन ईच इज रिमेनिंग द सेम. सो पहला फैक्टर तो गया. वेट 1 सेकेंड, आई विल जस्ट मेक इट लिटिल मेक इट अ लिटिल. So what I was saying कि the first factor is gone, number of shells same है, तो उससे कुछ फर्क नहीं पड़ेगा. Number of shell is the same, so that won't affect it across a period from left to right. So number of shells same, unaffected. But we have two factors. First was number of shells, second was the nuclear charge. But nuclear charge increases. Why does nuclear charge increases? Check. 281, 282. इसमें 11. There are 11 protons, but this has 12 protons. What was nuclear charge? Nuclear charge was the charge of the nucleus. Charge of the nucleus which means what? Charge of the proton. क्योंकि न्यूट्रॉन has no charge. तो इसमें obviously अगर ज्यादा है प्रोटॉन्स तो इसका चार्ज भी ज्यादा होगा. So that's why, because, or we can say since nuclear charge increases, we will say atomic radius decreases. So from left to right, atomic radius decreases. Just remember this. This will 100 each. This will definitely come. ये यही आता है because trends definition factors, that's all. ओके. उल्टा भी पूछ सकते हैं, राइट टू लेफ्ट क्या होगा, फिर राइट टू लेफ्ट इंक्रीज होगा ऑब्वियसली बिकॉज राइट टू लेफ्ट द nuclear charge is decreasing, so it will of course increase only, right? So yeah, now the period is done. Now we will talk about group from top to bottom in a group. From top to bottom, what happens is first, so we'll talk about here the nuclear charge. Okay, we nuclear charge बढ़ रहा है. Lithium, sodium and potassium and so on and so on. But अभी इसमें 2,1, 281, 2881. Nuclear charge is increasing. Nuclear charge increasing. Shit. Gee. Nuclear charge is increasing. So atomic radius should decrease. Should decrease. But there was one more factor. That was number of shells. इसमें 2 शेल है, इसमें 3 है, इसमें 4 है. So we say number of shell dominates. Therefore, overall, these are all important words. Dominates लिखना पड़ेगा. Overall लिखना पड़ेगा. ये भी should is also important. While explaining, if suppose they say that from top to bottom in a group, nuclear charge increases, then why does the atomic radius not decrease? Then you will have to explain the entire thing that nuclear charge, though it increases, atomic radius though should decrease, but does not. Why? Because number of shell dominates. Increase in number of shell dominates. Therefore, the overall atomic radius increases as you go from top to bottom. Fine. This was easy. Now there are a few things in this which you need to remember. Key, even though when you go from left to right, the atomic radius decreases, but the noble gases have bigger atomic radius. So they are not the smallest elements. So it has like neon has a larger atomic radius in period 2. Why is that so? Because this is the nucleus, first shell, second shell. I'm showing neon now. अभी neon के 8 complete है. Stable है बहुत. Stability is not an issue here, but okay. So 8 complete है. It is very stable, but इसमें क्या होता है ना? There are electrons too close to each other. Repulsion होता है. Oh, crowding of electron. We say it is crowding of electron. And because of that, a force of repulsion is generated. Force of repulsion. Because it repulses, they have a greater, because repel होके वो पीछे जाते. That's why they have now. This is of course very difficult to visualize, but remember it. It is what it is. कि force of repulsion होता है. So noble gases have greater atomic radius. So in period 2, lithium has the largest atomic radius because of course it is at the left. It left to right से कम होता जाता है. That's why it has the largest. And, yeah. one more thing. Now suppose sodium, wait, I'll take lithium only. Take lithium. Suppose I have here lithium nucleus, first shell. Oops. First shell, दो है. Second shell, एक. So now what happens here? Suppose this is lithium atom, but suppose it forms a lithium cation, then इसका स्ट्रक्चर कुछ ऐसे दिखेगा, राइट? चेक. सिर्फ दो ही होंगे. So cation has a smaller, remember this now, cation has a smaller atomic radius than the original atom, but anion has a greater atomic radius than a original atom. Just given in the textbook also. Cation smaller than the parent neutral atom since remaining electrons are strongly attracted. अभी इधर तीन थे इलेक्ट्रॉन्स, अभी इधर दो ही है. अभी तीन पे न्यूक्लियर चार्ज और दो पे न्यूक्लियर चार्ज, हु विल एक्सपीरियंस अ ग्रेटर पुलिंग फोर्स? दो वाले पे, बिकॉज तीन वाले के इसमें उनका भी अपोजिंग फोर्स था, इसमें दो ही है तो ज्यादा नजदीक खींचे जाएंगे. बट डोंट, इफ यू आर फाइंडिंग इट टफ टू रिमेम्बर, इतना याद रखो, कटायन स्मॉलर देन द ओरिजिनल एटम, अनायन greater than the original atom. That was all for atomic radius. Very simple thing here actually, but fine it is. So that was all atomic radius. Now we do ionization potential. Again, tricky, conceptually difficult little, but इतना deep में नहीं पूछते कभी. Now, first thing which you need to do is the definition. Definition, though I'm not writing, I'm writing just one word which you need to memorize is this: required. Ionization potential is the energy required to remove a loosely bounded electron from the outermost shell of an isolated gaseous atom. Required. Now you will come to know why I'm paying so emphasis on this in a while. But इसका definition याद रखो. इसके factors, again similar factors. अभी now we won't have shells, but we will have atomic radius because we have studied it. Atomic radius increase. Okay, wait, let me first tell what do you mean by ionization potential. So definition again: energy required to remove a loosely bounded electron from the outermost shell of an isolated gaseous atom. तो सपोज ये एक एटम है. So for example, this is a nucleus, this is first shell, this is the second shell. अब इधर एक इलेक्ट्रॉन है, सपोज एक मेटल है, एक ही इलेक्ट्रॉन है, लिथियम से फॉर एग्जाम्पल. सो इसको लूज होने में जो एनर्जी लग रही है, lithium wants stability. It does not want this electron. It wants to lose it. It doesn't like it. It wants to keep you go away. Does not want that electron. So it easily loses it, right? It doesn't want that electron. So उसका energy required will be very less because it easily loses it by default. It loses only. It does not have to put any extra effort. But similarly, if I draw a fluorine, for example, I expect you to know fluorine or in atomic numbers. It is 9, so it will have 7 electrons. 6, 7. अभी फ्लोरीन को स्टेबिलिटी के लिए either it can become like lithium can lose one electron and it can become stable क्योंकि दो ही duplet rule complete हो रहा है. Similarly, fluorine here can also either lose 7 electrons and become stable by duplet rule, or it can gain 1 electron. So इसको 7 इलेक्ट्रॉन अगर लूज करते हैं, it will require a lot of energy. That is what is ionization potential, energy required to remove an isolated gaseous atom. So this will have a very high IP. This will have very low IP क्योंकि इसको फ्लोरीन को लूज नहीं करना है, उसको लेना है. It wants this electron to join here so that it can become stability like neon. So okay, so we go with trends now. Factors, sorry. So atomic radius, if it increases, नाउ विजुअलाइज थोड़ा, अभी एटॉमिक रेडियस अगर बढ़ रहा है, सो आउटर मोस्ट शेल है, नाउ सपोज, ओके वेट, हाँ, आउटर मोस्ट शेल है जो एटम का, अगर बड़ा एटम है बहुत, तो उसका वीक होगा ना फोर्स। अभी ओके, सो सपोज आई हैव अ मैग्नेट हियर विथ मी। अभी एक मैग्नेट इज 1 मीटर अवे फ्रॉम मी, सो दैट मैग्नेट विल कम इजीली, मतलब बहुत जल्दी अट्रैक्ट होगा। बट नाउ इफ अ मैग्नेट इज 15 मीटर्स अवे फ्रॉम मी, देन उस पे फोर्स बहुत कम होगा, और उधर अगर नजदीक एक 2 मीटर पे और एक मैग्नेट है, देन दैट मैग्नेट will break my force of my magnet and it will go with that magnet. बट अगर पहले केस में भी अगर एक मैग्नेट होता बट दूर होता, बट मेरा मैग्नेट का फोर्स उस पर ज्यादा है, तो इट वोंट गो देयर। तो सिमिलरली इफ एटॉमिक रेडियस इज बिग, इफ इट इज लार्ज, व्हाट विल हैपन इज कि आउटर मोस्ट शेल ना लूजली अट्रैक्टेड होते हैं, न्यूक्लियर चार्ज उन पे बहुत कम होगा, बिकॉज ऑफ विच दे विल इजीली गो। सो अगर एटॉमिक रेडियस ज्यादा है, तो आयनाइजेशन पोटेंशियल क्या होगा, कम होगा कि ज्यादा? थिंक, इजीली गो, एनर्जी, एनर्जी रिक्वायर्ड, रिक्वायर्ड एनर्जी, इजीली गोइंग। सो एनर्जी क्या लगेगी, कम लगेगी ज्यादा लगेगी? अगर इजीली जा रहा है कम लगेगी, सो आयनाइजेशन पोटेंशियल विल डिक्रीज। सिमिलरली सेकेंड फैक्टर रिमेन्स द सेम, न्यूक्लियर चार्ज। इफ न्यूक्लियर चार्ज इज इंक्रीजिंग, अगर मैं मेरा मैग्नेट बहुत स्ट्रांग बना दिया, सब मैग्नेट्स विल स्टिक टू मी, कितना भी कोई भी मैग्नेट्स आए, इट विल नॉट टेक अप। सिमिलरली अगर एटम का न्यूक्लियर चार्ज बहुत स्ट्रांग है, तो जो दूर के इलेक्ट्रॉन्स भी है ना, दे विल stick to the atom, so they will not easily lose, not easily lose energy required. So energy ज्यादा लगेगी कम लगेगी? ज्यादा लगेगी, आयनाइजेशन पोटेंशियल विल बी more. We they don't ask इतना conceptual, this was main concept of ionization potential, but main thing is definition, definition में भी main thing is required word, and the factors you should know, and the trends, of course. So trends I will do now. So trends in this mainly is, so across a period from left to right, across a period from left to right. I mean left to right, what happens? Atomic radius, we have studied earlier, atomic radius decreases. So atomic radius decreases, therefore ionization potential will also decrease or increase? It will increase. Check up, let's check up. अगर ये बढ़ा तो ये कम हो रहा है, सो अगर ये कम हुआ एटॉमिक रेडियस, तो क्या होगा, बढ़ेगा ना? it has to increase. Atomic radius will sorry, if atomic radius is decreasing, then IP has to increase. Why it increases, I have told already. Now see, अभी let's take group period 2 का एग्जांपल, पीरियड 3 का लेते हैं, चलो। इधर सोडियम है, लास्ट में इधर क्लोरीन है। अभी सोडियम का बहुत बड़ा एटम है, विजुअलाइज करने के लिए आई एम ड्रॉइंग इट ऐसा, एंड क्लोरीन का रिलेटिवली स्मॉलर है। तो इसका फोर्स लास्ट शेल पे और इसका फोर्स लास्ट शेल पे, किसका ज्यादा फोर्स स्ट्रॉन्ग रहेगा? इसका, राइट? सो इसको अगर एक इलेक्ट्रॉन को यहाँ से लूज होना है, so this will require more energy, this will require very less energy, तो बहुत दूर है, तो अगर ये चला भी गया, it doesn't care, it will be very far away, right? So this will require less energy, that is what we are speaking here. If atomic radius decreases as we go from left to right, ionization potential decreases, more energy will be required. Ulta de, right to left, ionization potential decreases. Now, down a group, down a group, down a group, what happens? First, same thing. अभी पहले भी ये हुआ. I'm going fast now. Nuclear charge increases, so ionization potential should what? Should increase, right? But atomic radius also increases. So it dominates over the nuclear charge increase. So what happens overall what? Overall at ionization potential decreases. So now check lithium, sodium, पोटेशियम. अभी लिथियम है, उसको अगर लूज करना है एनर्जी, अभी वेट आई विल अगेन ड्रॉ इट. लिथियम का समझो इतना है, थोड़ा छोटा है, बड़ा है एज कंपेयर टू लिथियम बेरिलियम बोरॉन वो सबसे इट इज बिगर. पोटेशियम से इट इज स्मॉलर बिकॉज इट इज टॉप ऑफ द ग्रुप ना. एज यू गो डाउन एटॉमिक रेडियस इंक्रीजेस. पोटेशियम का ये इतना बड़ा है. अभी लिथियम को अगर लूज करना है एक इलेक्ट्रॉन, so will it require more energy, less energy? It will require more energy, obviously, because it is very close to it. चार्ज बहुत है. क्योंकि अगर पोटेशियम को लूज करना है तो इट विल इजीली लूज. दैट इज वाई पोटेशियम इज मोर मेटालिक देन लिथियम. विल कम टू इट नाउ. मोर मेटालिक देन लिथियम बिकॉज इसका आईपी कम है, एटॉमिक रेडियस ज्यादा है, सो इलेक्ट्रॉन इजीली लूज. मेटल्स आर एसेंशियली इलेक्ट्रॉन डोनर्स. So the more easily an electron is donated, more metallic is that metal. Okay, fine. So overall IP decreases as you go down a group. So remember this now. Okay. Now the next thing we have to do is electron affinity. Now you will come to know why I highlighted that required word. So definition from textbook. Okay, do it from the textbook. Electron affinity is the amount of energy released when an atom in the gaseous state accepts an electron to form an anion. Now, many people, 90% of the people will make a mistake in this. ये name the following में आएगा. 100% it will come in name the following in the exams. Board also. They will give energy required to remove. Next one, energy released. People will make a blunder. They will confuse between required and released and they will go wrong. So ये फिक्स रखो, इलेक्ट्रॉन एफिनिटी है तो रिलीज होगा. आयनाइजेशन पोटेंशियल है तो इट इज एनर्जी रिक्वायर्ड. ओके एनीवे, सो वी गो विद द फैक्टर्स ना. अभी इसका conceptually is this actually the same thing. Amount of energy released when an atom in the gaseous state accepts an electron. So now tell me, अगर एक इधर मेटल मेटल है और एक नॉन मेटल है, तो कौन ज्यादा एनर्जी रिलीज करेगा? Obviously non-metal. Why? Because metals do not lose electrons only. That is why non-metals always they will have high electron affinity because metals तो do not lose electrons only ना. Definition क्या कहता है कि amount of energy released when an atom in the gaseous state accepts an electron. Oh sorry, the metals do not accept an electron, right? So that's why metals का electron affinity हमेशा कम होगा. Non-metals always accept electron, but metals never accept electron. They are electron donors. So amount of energy released will be always less for metals because they do not accept an electron anytime. वो नहीं लेते. They just donate electron. So we forgot to mention a few things up. So we'll do it once again. Where should I look? So we so helium has highest IP in the entire periodic table, whereas I think it is cesium. Cesium has the smallest. It has the smallest. इतने arrows मतलब smallest or highest IP. Actually, francium, but francium is radioactive, so we don't consider francium. And okay, so in general, noble gases have large IP. Anyways, the trend also says that only. So fine. Um, okay, fine. So factors affecting electron affinity, same thing. Now I'm not going. First is atomic radius. Atomic radius increases, electron affinity decreases. बड़ा अगर एटम है तो मेटल है. Metals do not accept electrons, therefore they do not release any energy. Therefore the electron affinity is very less. अगर if it is nuclear charge, second factor is nuclear charge. Nuclear charge increases, electron affinity decreases. Electron affinity increases. Sorry. Electron affinity increases. Same thing. If nuclear charge is increasing और बहुत nuclear charge है तो attraction होगा ना. अभी suppose I have a very strong magnet with me and there are 5 7 magnets kept around which are not attracted to my magnet. बहुत strong magnet है तो सब attract हो जाएंगे and they will start sticking to the magnet. Similarly वही concept है कि न्यूक्लियर चार्ज ज्यादा है, इलेक्ट्रॉन एफिनिटी ज्यादा होगा. वर्ड itself says electron affinity. Affinity means love. Electron sticks to the atom because of a high nuclear charge, because positive negative attracts और nuclear charge is always positive. So अगर जितना ज्यादा positive charge है उतना electron affinity will be more. Okay. So the trends, same trends again. Should I? Okay, fine. Okay, anyways. Across period, same thing. From when you go from left to right, the atomic radius decreases. So electron affinity increases. And chlorine has greater electron affinity than sodium. Why so? Because वो उधर है, राइट में एकदम. Okay, so before doing periodic table now you should have a very clear clarity of the periodic table. First 20 elements तो at least मालूम ही चाहिए किधर कौन सा एलिमेंट है. Because in the exam ना they don't, ये तो पूछते ही है but they also ask arrange the following in increasing order. 3 marks it comes. Arrange the following in decreasing order of electron affinity. So if you don't know कौन सा element कहाँ है then it will cause a problem. Chlorine has greater electron affinity than sodium because chlorine is to the right group 17, sodium is group 1. Atomic radius of chlorine is smaller, so खींचता है क्योंकि नजदीक है ना, distance is less, so it strongly attracts and so it has a greater electron affinity. Okay. Now group. So down a group, same thing. I'm not writing again. Actually, same thing as ionization potential. So anyone reading this should not get confused. So I will speak also. Ionization potential में क्या था? Down a group atomic radius increases, IP decreases. इसमें भी same है. Down a group down a group atomic radius increases. बड़ा है so electron affinity will decrease because firstly as you go down metallic character increases. Metals never accept electrons. Energy release will be very less, so electron affinity will be very less. Okay, so while reading this, check up check up the trend. In this also the increase in atomic radius dominates over the nuclear charge. हाँ, and noble gases have zero electron affinity. Why? Because they do not share electron, do not lose electron, do not gain electron. So उन्हें ना इलेक्ट्रॉन चाहिए, ना इलेक्ट्रॉन देना है, ना शेयर करना है. So उनका जीरो होता है इलेक्ट्रॉन affinity. So we have one more thing called as electronegativity. Called as electronegativity. Again, definition important. याद कर लो. It comes for name the following. It is the tendency of an atom to attract electrons to itself. Now, this is a bigger concept actually, but try to just remember the words. Tendency of an atom to attract electrons towards itself. Factors affecting same as electron affinity. This is I'm not saying even the textbook says the same as electron affinity. Which were those? atomic radius अगर ज्यादा है इलेक्ट्रॉन अफिनिटी कम होगा इलेक्ट्रोनेगेटिविटी भी कम होगा न्यूक्लियर चार्ज अगर ज्यादा है इलेक्ट्रॉन अफिनिटी ज्यादा होगा इलेक्ट्रोनेगेटिविटी भी ज्यादा होगा so trends are also the same. Trends also same to same, left to right. Atomic radius decreases. Electron affinity increases. Electronegativity therefore increases. Top to down. Atomic radius increases and it dominates over the nuclear charge. Therefore the electron affinity decreases and electron negativity also decreases. Fine. So that is all the chapter actually. Noble gases do not attract electrons and so in general we can say so in general terms we ये ऐसा याद रखो लो आईपी लो इलेक्ट्रॉन एफिनिटी लो इलेक्ट्रोनेगेटिविटी high atomic radius. If you see these all things, then it has to be a metal. So these are characteristics of a metal. और इसके completely opposite है non-metal के. Not writing them again. Opposite of this. High IP, high electron affinity, high electronegativity, small atomic radius. Um, Now, why do they have low IP? You know, now why do metals have low IP? They have low IP because they easily lose electron. If it is losing easily, then energy required is very small. That's why they have very low IP. Non-metals have high IP because they do not lose only electrons. So that's why they require a lot of energy to remove it and that is why they do not lose electron because उन्हें बहुत एनर्जी लगती है इसलिए वो बोलते हैं कि उससे अच्छा they will take an electron so they have high IP uh, so in general we can say like left to right the metallic character decreases visualize sodium chlorine क्या हो रहा है metallic character decreases but chlorine is non-metal of course it decreases and from top to bottom top to bottom we say metallic character increases अगर यहाँ इधर अगर metallic character decrease है तो obviously non metallic character is increasing your metallic character increases मतलब सोडियम पोटेशियम रुबीडियम ऐसा अगर जा रहा है तो सोडियम is less metallic than potassium so as you go down IP decreases radius increases metallic character increases so essentially, I think that is all the chapter. The last page number 15 summarizes the entire thing in Virav Dalal textbook. Entire thing it summarizes. So you can just go through it. So I've also done the entire thing only, but just if you want, you can check it out. This was all the chapter. Very simple chapter. Do it well. It comes for at least 10 to 12 marks. So don't lose on to those marks. And yeah, I think this was the chapter. Now we will proceed ahead with the next chapters as well. This was the easiest one. अभी आगे थोड़े थोड़े difficult हो जाएंगे फिर organic आएगा direct stoichiometry आएगा. They are also not difficult. They are just you need a little bit of practice. Organic is all memorization only. Okay, thank you.